This is the last of 3 videos on confidence intervals for population proportions. And this video basically explains the logic behind why most political polls or polls of the country or even of a state or a city involve hopefully 1,000 people. And this may have been mentioned in your class. I know I mentioned it in mine. If you look at the bottom of a survey, a national survey done by a national polling agency like Gallup, for example, they'll frequently describe how many people they polled and what their margin of error is. And more often than not, they poll roughly 1,000 people because the polling industry has decided that a 3% margin of error is a reasonable margin of error, and a poll of 1,000 gets you there. Well, we're going to look at the math behind where that comes from. So again, we're coming up with a confidence interval. Here's the formula we've been using. The margin of error is here. And a pollster or anybody that's paying for a poll may decide what margin of error they want, and that will dictate the sample size required. So it's basically as simple as this. We're going to take the margin of error that we're targeting, right? We'll use a P here that we'll talk about in a minute. We'll have a confidence level that we want. And given that, we'll solve for the sample size. So we solve for the sample size that gives us the margin of error and the confidence level that we desire. Now, we can do this algebraically by plugging in for M, Z star, and P star. If you'd like, all this can be converted. This formula gives you N. I'm not sure that that's helpful, but we'll put it up here. My preference is to start here and just use algebra to get to N. But there are 2 ways to do it. If you'd like to memorize the formula you see at the bottom, you can certainly do that. That won't be provided to you, the one on the bottom. Well, let's go through an example here. Isaiah and Sasha are candidates for mayor of Eden Prairie. You're planning a sample survey to determine what % of voters plan to vote for Sasha. You'll contact a random sample of registered voters. You want to estimate the % of voters who will vote for, oh, I forgot to change the name, Sasha, with 95% confidence and a margin of error no greater than 3%. How large a sample do you need? Let's fix this. So I want to be within 3% of the true proportion of folks who are going to vote for Sasha. How big a sample do I need? Well, let's put the parts together here that we know. We're interested in a margin of error of 0.03. When we do this, we need to use the margin of error as a decimal because of the math. Our confidence level here is 95%. We're solving for sample size, and we're going to use this formula. It requires P star. Now, we haven't even taken the survey yet, so we don't have a P hat. We don't have a P, so the question is, what do we put in for P star? And there are 2 answers. If we have no idea about what P or P hat might be, we're going to always use 0.05 for P star because it'll give us the biggest possible sample size. If there have been prior surveys done or we have some idea about what P might be based on a prior P hat, we can use that. It'll result in a slightly smaller sample size. But if we have no clue about what the proportion might be, then we'll default to 0.5. So in this case, we have no clue, so we're going to use 0.5. So at this point, it's just sort of basic algebra. I want a margin of error of 0.03. The formula for margin of error is Z. We have a 95% confidence interval here, so Z is 1.96 times the square root of P star times 1 minus P star over N. So now we need to solve this. So there are multiple ways to do this. Pick a path that you like, but just do it well. I'm going to divide both sides by 1.96. And when I do that, I end up with, on the left, 0.0002343. On the right, I have the square root of 0.5 times 0.5 is 0.25 over N. Well, I'm trying to get to N, so I'm going to, whoops, I didn't do that right. Let's do this, sorry. This is 0.03 over 1.96. Now I'm going to square both sides to get to N, and when I square both sides, then I end up with 0.0002343 equals 0.25 over n. Squaring both sides eliminates the square root on both sides. Now if we solve for n, if you'd like, you can cross multiply. And if we do that and carry it out, I end up with n equals 0.25 divided by 0.0002343. And if you solve that fraction, you get 1067.11, and we always round up. So our sample size that we're targeting would be 1,068. So there's your roughly 1,000 sample size to get your margin of error of about 3%. Well, let's say we didn't want 3%, but we wanted 2.5% instead. Reminder up here, for a 3% margin of error, our sample size is going to be 1,068. So speculate, what we need, a bigger sample or a smaller sample? Well, it should be somewhat clear to you at this point that if I want a smaller margin of error, I'm going to need a bigger sample size. I'm going to talk to more folks. So in this case, I want a 2.5% margin of error. It's still a 95% confidence level, so I still have 1.96 times 0.5 times 0.5 over n, and without going through all the algebra here, if you do this, you get a sample size of 1537. And if I want a 2% margin of error, I could do the same thing and recalculate 0.5 times 0.5 over n all under the square root, and if you do that, you get 2401. So just quickly showing the logic through the math of what happens. A smaller margin of error requires a larger sample size. If I want to be more precise, I should talk to more folks. So the logic of that ought to make some sense to you. Smaller margin of error, more precision in my estimate. I should gather more data before doing that. So this is a poll that was done back when the U.S. got involved with Libya, and there was a poll about whether Obama was getting any benefit politically, and he wasn't. But this is the last paragraph from that poll. And here they had 1,012 people involved, close to the 1,068 we came up with, and a plus or minus 3 percentage point margin of error. And the math and the calculation of their margin of error is exactly the same as the math that we just did. So now you understand how sample size might get determined in a poll of some importance, and that's kind of neat.